Stop connecting your Azure virtual networks directly to each other. I just helped a company untangle 45 peering connections that were costing them $2,000 a month in data transfer fees and creating a security nightmare they couldn't audit. The fix took 20 minutes once we understood hub and spoke topology.
Hey everyone, welcome back to the Network Ninja Cloudcast. I'm really excited about this one because I've been struggling with exactly this problem.
Great to have you here. Today we're going to solve the VNet peering mess that happens when your Azure environment grows beyond 3 or 4 networks. By the end, you'll know exactly how to design this properly from day one.
So what's the actual problem? I thought VNet peering was supposed to be simple. You just connect two networks and traffic flows, right?
That's the trap. It is simple when you have 2 or 3 VNets. But here's the math that kills you. VNet peering is non-transitive by default. If net A peers with net B, and net B peers with net C, traffic from A cannot reach C through B. So what do most people do? They create a direct peering from A to C.
Okay, but that doesn't sound terrible for 3 networks.
Right, but the formula for full mesh connectivity is n times n minus 1 divided by 2. With 10 METs, that's 45 peering connections. With 20 METs, that's 190 connections. Each one costs money for data transfer, each one needs security rules, and each one is a potential misconfiguration waiting to happen.
That escalated fast. So hub and spoke fixes this how exactly?
Think of it like an airport system. Instead of having direct flights between every small city, which would be impossibly expensive, you route everything through major hubs like Atlanta or Chicago. Your spoke cities connect to the hub, and the hub handles routing between them. In Azure terms, you have one central hub VNet, and all your workload VNets, the spokes, peer only with the hub.
But wait, you just said peering is non-transitive. If spoke A peers with the hub, and spoke B peers with the hub, how does traffic get from A to B?
Excellent catch, and this is where people get it wrong. You need a network virtual appliance in the hub, typically Azure Firewall or a third-party NVA, to route traffic between spokes. The NVA acts as the next hop. You then configure user-defined routes, UDRs, on each spoke subnet pointing traffic destined for other spokes to the NVA's private IP address.
Can you give me a concrete example with actual IP addresses?
Absolutely. Let's say your hub VNet uses the address space 10.0.0.0 out of 16. Your Azure Firewall sits in a subnet called Azure Firewall Subnet, which is a required name by the way, using 10.0.1.0 out of 26. The firewall gets a private IP like 10.0.1.4. Now spoke A uses 10.1.0.0 out of 16 and spoke B uses 10.2.0.0 out of 16. On spoke A's workload subnet, you create a route table with a route saying destination 10.2.0.0 out of 16, next hop type virtual appliance, next hop address 10.0.1.4. You do the mirror image on spoke B.
So every packet between spokes goes through the firewall. Doesn't that add latency and cost?
It adds about 1 to 2 milliseconds of latency, which is negligible for most workloads. The cost is Azure Firewall at roughly $1.25 per hour plus $0.016 per gigabyte processed. But here's the trade-off most people miss. You now have a single point for logging, inspection, and policy enforcement. You can see all east-west traffic in one place. For compliance-heavy environments, this visibility is worth far more than the firewall cost.
What about traffic going to the internet or to on-premises? Does that go through the hub too?
Yes, and this is the second major design decision. For internet egress, you typically put Azure Firewall or a NAT gateway in the hub. All spokes route 0.0.0.0.0 to the hub. For on-premises connectivity via ExpressRoute or VPN, your gateway sits in a gateway subnet in the hub VNet. Here's the critical setting people miss. When you create the peering from hub to spoke, you must enable allow gateway transit on the hub side and use remote gateways on the spoke side. Without these flags, spokes cannot reach on-premises through the hub's gateway.
I've seen those checkboxes and had no idea what they did. What's the biggest mistake you see people make with this topology?
2 things. First, forgetting to enable IP forwarding on the NVA's network interface. Without this, Azure drops packets where the destination IP doesn't match the NIC's IP. You enable it in the Azure portal under the NIC's IP configurations. Second, overlapping address spaces. If spoke A uses 10.1.0.0 out of 16 and someone creates spoke C with 10.1.0.0 out of 24, you've got a routing nightmare. Document your IP address plan in a spreadsheet or use Azure EPM before creating any VNet.
Let me make sure I've got this. Hub and spoke reduces peering complexity from n squared to just n connections. You need an NVA in the hub to route between spokes because peering is non-transitive. UDRs on spoke subnets point inter-spoke traffic to the NVA, and you enable gateway transit settings for on-premises connectivity through the hub.
Perfect summary. My pro tip is to start with Azure Firewall Manager if you're building this from scratch. It automates the route table creation and gives you a central policy view across multiple hubs if you eventually need them.
This makes so much more sense than the mesh I was about to build. I'm going to diagram this out today.
That's it for today's episode. If you found this helpful, please hit that like button and subscribe to the channel. We've got more Azure networking deep dives coming.
And share this with anyone who's connecting VNets without a plan. Save them from the 45 peering nightmare.
Thanks for watching the Network Ninja Cloudcast. See you in the next one.